Hi student, welcome to class again. This is Emerald and welcome to Learn Chemistry with Emerald. In the previous class, I have looked at um, mass molar concentration problems. Although we have not finished that, we'll come back to that later. But let's quickly look at gas laws. I think this one is also making students have a lot of sleepless nights. Okay. First and foremost, we have about 8 gas laws at the O level, ordinary levels, and of course, I want you to, of course, pay attention to them. I'll be focusing on the more technical questions that are very difficult to solve. So, first and foremost, let's look at some of this equation. The first law is Boyle's law. Boyle's law, and Boyle's law says that at constant temperature, the pressure of a given mass of a gas is inversely proportional to the volume at constant temperature. So mathematically, we are concerned about that. We say P is inversely proportional to 1 over V. Therefore, PV is equal to K. And then from there, we can say P1V1 is equal to P2V2. This is what is it called? This is our Boyle's law. So this is Boyle's law. Now for another one is the Charles law. Charles law states that the volume of a given mass of a gas is directly proportional to the temperature at constant pressure. So that means V is directly proportional to T, and then V over T is equal to K. Then you can have V1 over T1 is equal to V2 over T2. So mathematically, this is our Charles law. Charles law. Now, again, we have what is called the pressure law. The pressure law was postulated by Gay-Lussac as well, but we call it pressure law. So you have P directly proportional to T. That means the pressure is directly proportional to the temperature at constant volume. Okay, so you have P over T is equal to K. So you have P1 over T1 is equal to P2 over T2. This is pressure law. This is pressure law. Okay, this is pressure law. Now when you combine the 3 laws together, we have what is called the general gas equation. So the general gas equation is therefore P1V1 over T1 is equal to P2V2 over T2. This is the general gas law or gas equation. General gas law or general gas equation. Then again, we also have the ideal gas equation, or you call it equation of state, where you have PV is equal to nRT. PV is equal to nRT. That is ideal gas law. Ideal gas law. Now these are the foremost 5 laws, and then of course we have other ones. These are the foremost 5 laws. Now in the next class, I will also show you some others. Of course, take note that P is the pressure. Pressure can be measured. The unit for pressure now, you can have the one that is common is mmHg. The one that is common now is mmHg or ATM, which is atmosphere. We are looking at the units now. We look at mmHg, ATM, or you can have Newton per meter squared. Okay, that's for pressure. For temperature, you can have degrees Celsius, degree Fahrenheit, and Kelvin. Kelvin is the most common. In this one, you have mmHg, that is the most common. Of course, we have other ones. You have Torresi, that's Torr. We have Pascal, etc. So, but these are the most commonest that are used in chemistry. Now, this Kelvin is the most commonest here. So, in most cases, we convert the degree Celsius to Kelvin when you are giving. So, to convert to Kelvin now, the degree Celsius is plus 273. So anytime you are given the temperature in degree Celsius, you convert to what? Kelvin, by adding 273 to it. Okay, now for volume, you can have The one that has common is centimeter cube. You can have dm cube, and then you can have liter. You can have liter. 1000 centimeter cube is equal to 1 dm cube, and is also equal to 1 liter. It's also equal to 1 liter. Of course, N, which is amount of substance, is in mole, and then which one again? You have the R, which is the gas constant, and it is 0.082 atm dm cube per mole per Kelvin. Per mole per Kelvin. So these are generally the first 5 equations, or the first 5 laws. In the next video, I will talk about the other laws, and then I'll add a few information on these other ones as well. May God bless you. Have a nice time.